Um, Last week, yes, we had the pleasure of having Christoph Schuch, and today we're going to be hearing from Erin McCarthy, who I'll introduce in a moment. Just to give you a heads up about our next meeting, which will take place on Monday, November 3rd. The Hong Kong time is Tuesday, November 4th at 9 a.m., which is November 3rd for our speaker who's in San Diego, which is Jessica Pressman. So yes, that's a Tuesday, the 4th of November with Jessica Pressman, and that event will be moderated by Dr. Lydia Joe. So that's our forthcoming event. And of course, as usual, to give our plug, to give the normal plug for the Hong Kong Association for Digital Humanities Conference in January. I see at least a couple of people who'll be speaking, and I hope many others of you can attend as well if you happen to be in Hong Kong. So that's great. Okay, so on to today's speaker, Professor Erin McCarthy of the University of Galway. Educated in the United States, she's established professor of English literature and computational humanities at the University of Galway in Ireland. She is the author of a book, Doubtful Readers, Print Poetry, and The Reading Public in Early Modern England, which appeared with OUP in 2020. Is that right? And of course, numerous other articles and book chapters in literary studies and computational humanities. Relevant to today's talk, I should also mention that she is the PI of an Irish Research Council and European Research Council funded project entitled STEMMA, which is a nice philological reference. Systems of Transmitting Early Modern Manuscript Verse, 1745 to 1700. And as an early modernist, I should say, it's a great pleasure to have a talk here in our DHI talk series that touches on early modern things. To wit, the title of her talk, Cleaning and Reconciling Literary Historical Data with AI, Reflections from the aforementioned STEMMA project. Professor McCarthy, Erin, the floor is yours.
Thank you. Thank you so much for having me, and thank you for being here. I was sharing my slides. I will get them shared again. All right. There we are. So today I will talk to you a bit about the STEMMA project. We'll begin with kind of an overview of what STEMMA is before progressing to the AI material, which I'm sure is what you're really here for. So if it gets a little bit old-timey literary historical, bear with me. We will get to the exciting cutting-edge AI things. So English poetry continued to circulate in manuscript, that is in handwritten copies, long after the introduction of printing with movable type in England in the late 15th century. Many authors continued to prefer manuscript circulation to print publication because they believed that they could better control who read their writing and, by extension, how their works might be interpreted. This does not always seem to have been the case in practice. Famously, despite the poet John Donne's misgivings, the circulation of his poems would reach such a level that they have been preserved in 4,249 at last count, surviving manuscript copies, with an unknown number missing, destroyed, or yet to be found. The yet to be found is important. Some of you may remember that a few years ago they found some of Donne's works in a trunk in the attic of Westminster Abbey that just no one had opened in a few hundred years. They opened it and there they were. So it's possible that there are things out there that we just don't know about at the moment, which is exciting. Moreover, while print publication required a large capital investment up front, early modern manuscripts could be, and often were, created by a diverse range of men and women. Essentially, anyone who could read and write and get access to to paper and a quill and some ink, which you could make for yourself. And ideally, a text to copy could participate in the manuscript circulation of poetry. These people came from a broad swath of the socioeconomic spectrum, and they possessed varying degrees and kinds of literacies, as evidenced by their handwritten copies of existing and original poetic works. As Harold Love and others have shown, printed poems, ballads, news, jokes, libels, and recipes often re entered manuscript circulation after publication in print. Such texts were also frequently enclosed with letters, transcribed into manuscript miscellanies, excerpted into commonplace books, and copied into blank spaces in other documents, including printed books. The flexibility and portability of manuscript poetry led to its wide geographic dispersion as English books and people traveled to colonies in Ireland, North America, and the Caribbean, to religious and later political exile on the continent, and on educational and entrepreneurial adventures worldwide. Traditionally, scholars have considered most manuscript circulation to have taken place in four main contexts: the universities, the court, the inns of court, and gentry and aristocratic households. However, we are beginning to realize, as Stephen May and Arthur Marotti have observed, that most scribal culture must have been produced outside the centers manuscript scholars have tended to credit with virtually all of it. Furthermore, as Anne Coldiron and others have shown, although English was not read much outside England during this period, English literature was shaped by its contact with both classical literature and continental vernaculars. In my remarks today, I'll introduce the STEMMA project, beginning with a sense of why one might want to approach this problem of poetic circulation in terms of networks in the first place. I will then describe our data set. We were fortunate to be given permission to incorporate the most comprehensive sources of relevant data about these manuscripts, but as anyone who has reconciled multiple databases on any topic will know, this is far from a straightforward task. Finally, I'll introduce some of the methods that we have tried on the STEMMA project for cleaning this data set and offer some reflections on their strengths, weaknesses, and surprises. So to begin, I'll introduce STEMMA. So as some of you may already know, STEMMA, or Systems of Transmitting Early Modern Manuscript Verse, 1475 to 1700, was generously funded first by the Irish Research Council on a Consolidator Laureate Award, and now by a European Research Council Consolidator Grant. We are building the first large-scale computational model of the circulation of manuscript verse in order to answer four overarching research questions. How did manuscript poetry escape the control of its authors? Who read and copied manuscript poetry, and how did they gain access to it? How did the manuscript circulation of poetry change over time? And how can network analysis methods be adapted and applied to account for partial, damaged, or missing archival material? Ultimately, I think this project will help us overturn longstanding assumptions about English verse manuscripts as products made by and for discrete privileged groups. In so doing, I believe network analysis will show that the emerging audience for English poetry and English literature more broadly was both more varied and more geographically dispersed, and also more interconnected than traditional methods of literary historical research have allowed us to see. Resituating English poetry in the broader European context requires a significant methodological orientation, one that, as I will show, is at the heart of the STEMMA project. For the most part, scholars have, until now, tended to address manuscripts as case studies. There are many reasons for this, beginning with the lack of a single user-friendly manuscript finding list comparable to the resources available for scholars of early modern print. The gaps, overlaps, and differences in data structure between existing resources, along with the uniqueness and geographical dispersion of individual manuscripts, makes large-scale, deductive research on manuscript verse circulation exceptionally challenging. Instead, foundational studies by scholars including Mary Hobbs, Peter Beale, Arthur Marotti, and Henry Woodhuizen have addressed the circulation of individual authors, literary genres, material forms, social contexts, and revisionist histories that include a more diverse range of historical agents. The recently completed Dun Variorum project represents the most fulsome effort to address all of the surviving manuscript evidence related to John Donne, you'll remember from that first slide. But its aims were primarily editorial. The editors did not set out to develop a totalizing account or theory of manuscript circulation, not for Donne, and certainly not for the culture as a whole. In other words, previous scholars have generally worked inductively from individual manuscripts or relatively small groups of manuscripts to develop hypotheses about the broader landscape of manuscript first circulation. While parts of manuscript culture have been described in great detail, it remains difficult for scholars to see how these separate parts fit together. In some ways, the challenge we face is similar to that D.F. Mackenzie diagnosed among print bibliographers in his 1969 essay, Printers of the Mind, Some Notes on Bibliographical Theories and Printing House Practices. In this essay, Mackenzie responded to fellow bibliographer R.F. McCarrow, who argued that the study of printed artifacts could only ever proceed inductively due to the fragmentary nature of surviving evidence. In contrast, Mackenzie held that bibliography, like all sciences, or all other sciences, I should say, or branches of knowledge, could productively use hypotheses and deductive reasoning to advance the state of the field. For Mackenzie, quote, to limit our knowledge to that which may be derived by inductive inference from direct observations is to invite the obvious objection that no finite number of observations can ever justify a generalization. Perhaps it is not coincidental that I started thinking about how we might move beyond our usual method of multiple sustained firsthand observations while rare books libraries and national borders were closed during lockdowns. But what if we could move beyond the level of the case study or the individual witness? What if we could study early modern manuscript culture as a whole? What would or could this mean? Network analysis offers one answer. Network methods have been adopted by digital humanities scholars in recent years. Ruth and Sebastian Onnert's foundational studies of tutor correspondence networks inspired sophisticated work by Evan Burke on the Hartlib Circle and John R. Ladd on dedications and printed books. These studies have identified important patterns in the ways information circulated in the early modern period. They also shed new light on individuals whose roles in their networks are more significant than has previously been appreciated. Blaine Gretteman's recent monograph makes extensive use of data from the English short title catalog to analyze networks of authors and stationers in the book trade, revealing the importance of previously less well-known actors and network effects that led to the rapid spread of information through the printing press. Around the same time, the 6 Degrees of Francis Bacon project used data from the Oxford Dictionary of National Biography to model the early modern social network. One particularly exciting development from this project is the option to calculate the probability that any two people in the network were connected. In recent years, early modernists have also used the language of networks to describe how text circulated within defined communities. Manuscript was an inherently social medium. Unless manuscript copyists were composing their own original works, they had to get a copy text from someone else, and they often shared what they had copied onward. Thus, scholars have by turns described the social groups that facilitated the creation and distribution, I should say, of literary manuscripts as circles, clubs, communities, coteries, fellowships, fraternities, peer groups, spheres, and tribes. These groups coalesced around relationships characterized as affiliation, alliance, coeducation, friendship, family, faction, patronage, program, sect, and commercial sociability. In writing this talk, I realized that I myself had, in Doubtful Readers, promised to explore how publishers presented verse when it moved beyond what I then called the personal and professional networks to which poetry had been restricted. Other recent studies have investigated the transmission of verse, news, intelligence, controversial pamphlets, recipes, religious texts, correspondence, and even in individuals' own notebooks. There has also been some consideration of provincial, national, sectarian, and colonial networks. However, even as humanities researchers began to incorporate insights from network analysis and network science into their analyses of early modern literature and culture, the manuscript circulation of verse resisted this kind of study. On the most basic level, humanities network analysis has most often, not always, but most often, been used to study the actions of identifiable human agents, like the senders and receivers of letters, or the printers, publishers, and booksellers involved in the trade in printed books. Manuscript verse miscellanies, I thought, could not easily be studied that way because of the paucity of information about authorship, attribution, transcription, and provenance. At least two insights helped me realize that creating a network model of manuscript circulation might not only be possible, but actually be quite useful. The first was theoretical. Andrew Piper and Carolyn Levine have both suggested in rather different ways that networks can serve both as conceptual models and as representational forms that are every bit as historically and politically situated as literary genres. Here, I'm using the term model in its scientific sense, where it is a simplified representation of a phenomenon that allows for manipulation and experimentation. Richard Jean So notes, and I'm quoting here, literary scholars have long cast a suspicious and critical gaze toward modeling, which strikes them as offensively simple-minded and naive. Models run counter to the deep and intensive reading that literary critics take pride in, the exposing of nuance and singularity in texts, writers, and human beings. However, Levine's work, along with Piper's and So's, helped me think about how we might move beyond a simple version of historical network analysis, where I would make one of those visually striking, but ultimately not very legible and therefore not always useful hairball diagrams and calculate some descriptive statistics about it and just kind of call it a day. Once I started thinking instead in terms of models and reading more widely in existing network research, particularly the network turn, a collaboration between four leading practitioners of humanities network analysis, I learned that Bayesian statistics could help us address the problems of anonymity and loss that I already mentioned. And creating something called a one-mode projection would help us move away from those hairball diagrams to make something more useful. So I was originally thinking in terms of, well, if I network text and manuscripts, all I'm going to see is which poems are in which books, and that's kind of boring. And also, you can see from the slide here, the more manuscripts you add, the less legible it becomes. However, by doing matrix multiplication, there's a co-occurrence matrix, just if anyone needs a refresher, we can create what's called one-mode projections and see how works connect to works via appearance in the same manuscript, or how miscellanies connect to miscellanies on the basis of having the same contents in them. So once I realized that these things were possible, I went, oh, okay, actually, network analysis might help us here. And so I did what every English professor did and set out to learn the relevant math. I did 5 semesters of university math to try to understand the linear algebra and statistics that would be involved in this project, and quickly determined that this was not a project that I was going to do in a sabbatical as I had originally imagined. Um, I thought in the very earliest stages of this project that I could do all the data work myself, and just hide out in my apartment in Australia. I was working in Australia at the time. The borders were closed, and I thought like, okay, I'm sitting on this pile of data, and this is how I'll get a book done while I can't get to a manuscript. And I quickly realized that this was going to take a lot more than a semester and probably more than one person, and ideally at least one person who wasn't actively trying to learn linear algebra while doing the research, and teaching full time. So aside from the math issues and also the theoretical challenges, there was a much more pragmatic, but perhaps equally difficult challenge to face. The data that we would need to model manuscript circulation is fragmented and often quite messy. Early modern manuscript studies still lacks a standard finding list like the short title or wing catalogs, which you can probably see behind me. But thankfully, we have a very good head start. Between the Catalog of English Literary Manuscripts and its print predecessor, the Index of English Literary Manuscripts, the Folger Union First Line Index, the Perdita Project, some catalogs that I made along with my colleagues on the research project during my own postdoc, which have just been living in Excel since 2014. Joshua Eckart's personal database, and the first line index created for the Dunbariorum. We actually have a lot of information about which poems are in which manuscripts. But these different sources, at least when I applied for this grant in 2021, couldn't talk to one another. And you also couldn't just copy and paste them together. Each has different principles of selection. Each preserves different and sometimes conflicting information. And they weren't even all in the same file format. So the manuscripts that they describe are also idiosyncratic. They're scattered around the world with no real pattern to it. A lot of them have ended up in the United States, which obviously isn't where they were created. And so that was the big challenge. And frankly, the reason that I had to go out and get grant funding was to try to wrangle this data. It was beyond the capacity of any one human to deal with it. So let's talk a bit about why this is. So we were very, very fortunate. I mentioned these 6 data sets that already existed, and we were given permission to incorporate all of them into our own database, which is incredibly generous on the part of the scholars who created them. Working with scholars identified through a national, sorry, not scholars, subcontractors identified through a national tender process, we have developed a PostgreSQL database and imported 5 of these 6 data sets. So you can see from the slide that they're quite different. Catalog of English Literary Manuscripts came to us as a set of XML files that just sort of live in my Dropbox. And we also thankfully got the style sheets so that we could understand them. We had some flat CSV tables with a range of scopes. So you can see one of them only has 4,240 lines, but another has 704,321 rows. The research first line indices, we actually made a separate file for each one, and so there were 170 of those. So it's about 1 million records in total that we inherited. Importing this data involved developing a standard data model because obviously each of these had its own data model and its own principles, pre-processing and enriching these original source files, and creating authorities and unique identifiers. However, these underlying data sets differ in formats, as you can see, and metadata schemes, as well as in their intellectual scopes and emphases. The Catalog of English Literary Manuscripts focuses exclusively on works by 237 canonical authors, mostly but not exclusively men. The Perdita Project catalogs manuscripts associated with women, including women who wrote, as well as women who wrote their own works, as well as scribes, book owners, and book users. In some cases, we just have a signature that just kind of indicates that a woman had gotten her hands on a book at some point, and we actually don't know if she owned it, if she read it, but we do know that she had it long enough that she could at least get her name in there. And Research, the reception and circulation of early modern women's writing, which is the project I worked on as a postdoc, records evidence that women's writing was read. The Union First Line Index includes English verse from manuscripts held in 8 repositories. But what we've learned as we've worked with it more is that because it is essentially a combination of spreadsheets created by multiple different English and history professors working completely independently of one another. And I did know that this is how it was created, but I thought there was more curation than it turned out there was. Um, it presents a lot of quality control challenges, starting with the presence of duplicate, triplicate, sometimes quadruplicate entries for the same items because they basically just dumped all of these things into one database and no one checked, and so it's chaos. More specialized digital resources have been created to support specific projects. Digital Dun preserves work products created by the editors of the Dun Variorum, while Joshua Eckart's Index of Selected English Poetry Manuscripts 1590 to 1660 started as a way for him to organize his own data for his first monograph, Manuscript Verse Collectors and the Politics of Anti-Courtly Love Poetry. Now, it's worth noting that the collation of this material is not the primary aim of the STEMMA project. The ERC doesn't fund infrastructure, and so if all we were going to do is build a database, they would probably not be very interested. But because these records will eventually be represented as nodes and edges in our network model, this data preparation is an essential prerequisite for everything else that we're going to do, including the advanced literary and quantitative analyses that are actually the point of the STEMMA project, which are planned for later in the project. So we also had permission to incorporate a sixth data set, which you'll see kind of grayed out at the bottom. And this is Perdita. This is the data set related to women's writing. We absolutely want this data in our database. Unfortunately, we haven't been able to ingest it using the same processes. We haven't been able to get access to the original source files, not because the creators are unwilling to share them, but because they don't have access to them themselves. And so it survives in a frames-based website, which is mostly but not entirely functional at this stage. It was built in 1997. And so although we had consent to scrape it, we actually found that we couldn't scrape it in a way that we could work with easily, which I think surprised everyone. Thankfully, this data set includes only 500 entries, and not all of these are relevant to STEMMA. So I think what will probably happen is that at some point, once the data that's already ingested is clean, we'll just manually enter anything from Perdita that seems relevant. It's not a perfect solution, but it might be a nice summer job for an undergraduate intern or maybe a research assistant. So the database, as it stands, currently contains details of 93,703 transcriptions, of 21,907 unique works or poems, found in 6,037 manuscripts. These manuscripts are located in 410 repositories worldwide, but mostly in the UK and the US. And they include contributions from 7,968 named people, including authors, scribes, book owners, and others. These numbers are continuing to fluctuate. They're starting to stabilize a little bit, but they're still fluctuating, mostly going down these days for reasons that I think will probably become clear over the next part of this talk. So we've mapped our data to a uniform set of fields to facilitate the removal of duplicates, the creation of authorities, where none exist yet, reconciliation, and assignment of unique identifiers. Our cleaning has generally focused on three tasks: identifying copies of the same work to support the creation of a work level entity, because those data sources were just telling us what was in what manuscript, but they often didn't go as far as to say, these are all copies of the Flea. These are all copies of, Shakespeare's 19th sonnet. And so we've had to kind of do that work to reconcile to an authority list ourselves, I should say. Second, we've been removing duplicate read multiple, because as I've said, sometimes it's more than two, and also out of scope records, and then standardizing metadata where possible and desirable. So this is, making sure that our dates are all working the same way. We don't want to change, and I will get into this, but we don't want to change spellings necessarily, but where there's ambiguity, we want to try to clean that up. So I had known that combining these databases would be difficult. I wrote in the proposal, quote, reconciling multiple databases is a complex undertaking. That said, it's proven to be even more complex than I had anticipated. One data source, the folder, which nominally covers a 225-year span, had more than 35,000 unique date values. Early modern spelling and scribal habits confound traditional data cleaning methods because they make string searching impossible. but they also provide valuable historical evidence, which makes it necessary to preserve them and not modernize them. So we had to think about how we wanted to approach this. And data cleaning could mean a lot of different things for different projects. Also known as data cleansing, data wrangling, data munging, and even sometimes data janitor work, data cleaning can refer to a range of necessary and important, but also difficult and often tedious activities, including, but not limited to, disambiguation, duplicate detection, identification of new neighbors, reconciliation, restructuring, and fuzzy searching, as well as removal of data. So lots of the kinds of things we've been doing. These processes necessarily precede analysis and interpretation, as they are directed, quote, not towards eliciting meaning so much as towards eliciting the right form. As we move towards a more robust environment of linked open data, we will need to be able to process more data more quickly in order to cope with the increase in access. And recent estimates hold that this work can consume 50 to 80% of the total person hours for any data science or shall we say, data science adjacent project. Digital humanities scholars have occasionally argued against cleaning, usually on the grounds that doing so removes complexity or nuance from the data set. And to a certain extent, we're dealing with that kind of issue, but not doing any cleaning at all was never an option for STEMMA. Again, while the project is not intended to produce an authoritative bibliographical resource in its own right, our analysis, visualizations, and conclusions will all be more reliable if we can get the underlying data into the best shape we can. The inclusion of these, or were we to use the data in its current form, any network model would be inevitably distorted by the inclusion of these multiple records for the same item, as well as competing and sometimes conflicting records. There are also records that are clearly out of scope, either because the texts that they transcribe are not poems, are not in English, were written too early or too late to be relevant to the project, or some combination of these things. Because of course, once it gets to 1700, that doesn't mean that someone stops writing in a book. But if someone has, thrown something in there in 1750 or 1800, it's not really telling us about the early modern world anymore. And so that has to be pulled back out where we can identify it. Moreover, this cleaning process highlights areas where data is incomplete, and it allows us to make decisions as a team about where further research is required to augment the data. Curating the best possible data will also benefit users of the data set when it becomes open, which we hope will be in the next year. And we hope that we will also be able to make it linkable and interoperable. And so while we cannot know what future users may wish to do with this data, it's important that we make it as reliable as we can so that these future research projects know that they can rely on the data as well, to do work that we probably can't even imagine yet. So the volume of our data presents one obstacle, but it is not the only challenge we face. The English language started to look and sound the way it does today during the years of our study. If you've taken a Shakespeare course at any point in your education, you probably already know this. However, as R.G. Nermer reminds us, English around 1500 was very different from English around 1700. At the beginning of the period, there was no standard orthography or spelling, even for one's own name. You can see here all the different ways that Shakespeare signed his own name, and he doesn't spell it the same way every time. And so, what hope do we have if we can't even agree on how to spell your own name? London English had not yet supplanted regional dialects, as it mostly would by 1700, and writers in further flung provinces and newly founded colonies produced texts that were markedly different from those written by their counterparts in the English capital. Moreover, early modern scribes altered their texts in both intentional and unintentional ways, making the question of what constitutes a copy of the same work less than straightforward. Researcher and institutional habits also shape our underlying data. Differences in scope, priorities, and even transcription practices make reconciliation more complicated. So on the slides, you can see some of the things we're dealing with. Here we have library, or sorry, this is if you focus on that first line column, you can see that you have versions of the same poem, but there are just slight little differences that make it impossible to match as a string. A computer is not going to recognize that "'tis true, 'tis day, what though it be" is the same as "'tis true, 'tis day, what thought it be." "'Tis true, 'tis day, what though it be" with a full stop in the middle, kind of a medial caesura, along with a few kind of related variations. "'Tis true, love thee, and am at lotes to show." Um, we also have here, we've cleaned this, thankfully, but three records for the same manuscript, in part because if you look in the shelf mark column, two of the records have a space in the middle of the shelf mark and one does not. So again, computer's not recognizing that as a match. And in the repository column, you have two records for the Huntington Library and one for the Henry E. Huntington Library. So as humans, we know that these are the same, but using traditional methods of reconciling data, we're not getting that. Finally, these are shelf marks, and you can see where just the inclusion of spaces, and also sometimes we have the prefix MS before a shelf mark, and sometimes we don't. This again is something that we can handle with regex, regular expressions, um, but it's not, a simple kind of like just match them situation. You have to at least use regular expressions. So these are some of the kinds of things that we identified pretty quickly. So because we hope that our data set will not only provide a firm foundation for our work, but be reusable in future projects, we aim to preserve as much historical evidence as possible. Therefore, one seemingly obvious solution, modernizing or otherwise regularizing our data, was rejected out of hand. Now, projects that I have worked on in my career have modernized, even though as scholars we don't like it. We sort of felt as digital humanities scholars that it was a necessary evil. So it's kind of amazing to think that in 10 years we've already moved from this being kind of the default solution to like, no, absolutely not. That is just not on the table. So another option we considered was off-the-shelf tools, most notably OpenRefine. OpenRefine was very useful in the pilot project that I did when I was applying for the funding, but I only had 15,000 records then. And so as the data has scaled up, it has been less able to cope, and perhaps more importantly, OpenRefine's tendency to overwrite bad or dirty data kind of made it not fit for purpose here. It was essentially doing the same thing as modernizing. It was stripping out all of that historical nuance that's really at the core of what we're trying to do on the project. So I want to be clear that this isn't a problem or a shortcoming of OpenRefine. It was built for business applications, and it's perfect for that. It's just not really what we need for historical or literary evidence, where we need something more nuanced. So the matching methods available in OpenRefine, we sort of thought, well, maybe we could deploy them in our database, but we found that they would be quite slow, quite computationally expensive, but also unlikely to give us the results we wanted. Levenshtein distance, sometimes called edit distance because it measures the number of operations. So, insertions, deletions, cleaning up mismatches, needed to transform one string into another string. And phonetic matching can account for small variations and scribal changes, but these methods would likely miss more extensive adaptations of interpolations of exactly the kind that early modern scribes really enjoyed making. So instead of attempting to work directly with the data itself, we decided to explore using machine learning techniques that have allowed us to preserve important paleographical and orthographical evidence. Working with these problems computationally has saved us months, if not years, of manual data checking by allowing us to target our work. There are the other unsuitable options fading away. So let's look at the solutions we have tried thus far. In a recent preprint, 38 researchers working at the intersection of the humanities and data science explored what it means to discuss generative AI as a cultural technology. And they proposed a new method of what they called computational hermeneutics. The hermeneutic circle is central to their method. And they emphasize that interpretation is therefore, and this is an extended quote, probably should have made a slide. Still, here's the quote: an iterative process between understanding the meaning of a specific part of the artifact and the meaning of the artifact as a whole. For example, one could iteratively analyze the imagery depicted in a given line or stanza of a poem, then update one's conception about what the poem means in general, each time using the updated general theory to analyze a specific line and vice versa. While the term is varied in its usage, what it typically means to analyze something hermeneutically is to engage in and provide an account of this iterative process of interpretation. These authors are specifically discussing the text and image outputs of Gen AI systems. However, given that the technology underlying our solutions is the same, it seems sensible that our benchmarking and developing processes would be similarly iterative. Um, I made a joke about our solutions being less flashy and exciting than some of the more exotic, let's say, Gen AI outputs. For example, this rap song that I was able to make about the project in about 30 seconds using Udio. We don't need to talk about the rap song. We can talk about that during the Q&A. And there it is. So some key terms from our database that might be helpful for the discussion that follows are manuscripts, which in our project means the entity for recording data about a specific material document, and manuscript items, which represent transcriptions within these documents. A key entity that was missing in most of our inherited data was what we initially called, and I referred to this a few slides ago, the work level entity, or now just works, which captures distinct literary works in the sense of G. Thomas Tansell, the bibliographer. That is, texts can vary from document to document, but we generally still agree that they are meant to represent the same artistic creation or work. So you can have different texts of Hamlet with different variations, but they're still fundamentally Hamlet and recognized as such. Another way you could think of this, if you come from an information science background, is just an authority list. And it is here that AI has become most useful to us in setting aside what textual editors would call accidental and substantive variants to try to locate all relevant witnesses at scale. One thing to know about our methods is that they've evolved very rapidly, like many AI projects. When Professor McManus first heard me speak about this work in Hong Kong in January, we had this diagram of a processing pipeline, but we hadn't even tried it yet. A few months later, I was describing a process using locality sensitive hashing in a text-based terminal interface, which I will show you in a few minutes. This was installed on one MacBook that we had to physically pass between members of the team. We are now 6 months later working with a lightweight agentic model with a web-based interface that allows all of the members of the research team to work simultaneously. So we have thus progressed from work that was arguably rather old school natural language processing to work that is indisputably engaging with the large language models that underpin the technologies currently promoted, sometimes hyped, as artificial intelligence. As a first step, we used locality-sensitive hashing to group manuscript items with similar first lines into buckets that seem to be copies of the same poetic work. So on the slide, you can see how locality-sensitive hashing works if you're not familiar with it. It reduces data dimensionality by using a random hash function. So we were using 256-degree signatures. It then does a similarity calculation on the basis of the angle between the two vector signatures that are created. So you might remember a vector is a mathematical quantity that has both magnitude and direction. And so if you ever took trigonometry, the bane of my adult calculus 2 studies, you might remember that a cosine is the ratio of the side of a right triangle to its hypotenuse. So with vectors, this cosine can tell us if the vectors are pointing in the same direction, suggesting that they are similar, if they are orthogonal to one another, or if they are completely opposite. And then finally, these new lower dimension signatures are placed into the buckets where each hash has a high probability of being similar to the other items in the same bucket. These methods are used to match genome sequences, to retrieve songs based on their melodies, to search images and videos, to create maps and geofences, to convert speech to text, to predict adverse medical effects, and yes, if you are a Turnitin user, this is how plagiarism detection has traditionally been done. Because this is a probabilistic method, we felt that we needed to check the system's work. That's just a slide about vectors, which we did in a bespoke terminal application, which you can see screenshot here. This really takes me back to my primary school days. So using this technique, we grouped 198,000 manuscript items into about 14,500 buckets, which we manually reviewed. We conducted this review using a local instance of the database and this command line application. And we were really impressed with this. When we got it, we were like, wow, look at this. You can see that it has found all the instances of Christopher Marlowe's The Passionate Shepherd to His Love, but also maybe some of John Donne's The Bait, because they both begin with "Come live with me and be my love," which is why we felt we needed human review. From here, we progressed to using vector embeddings. So slightly different from locality sensitive hashing because we're not shingling the words, we're looking at the semantic value of whole words. And so we progressed to vector embeddings that we created. We created two different sets. One with OpenAI's text embedding 3 small model, which just offered us a good balance of performance and low cost. And McBirth, which is a pre-trained model fine-tuned on an extensive corpus of early modern English texts. Again, we identified buckets of possible matches for expert review. And we created embeddings for two different scopes. One for all of the lines that we had of a given item. So always a minimum of one, but sometimes as many as 4 lines, first, second, penultimate, and last lines. And we also had another scope that included the title and heading along with the lines. However, we found this second scope often didn't add value and sometimes actually made things worse because early modern compilers have this tendency to use very vague headings in their personal manuscript collections, like song, sonnet, or sometimes just another. Well, modern editors, so people working today or in the recent past, often repeat the first line of a poem as a title when there's a doubt. So then it's just duplicating evidence. So we either had confounding evidence or duplicate evidence, and so we just found that that scope was not as useful as it might have been. So again, because a vector embedding maps the position of an item in semantic space, again in 256 dimensions, we can then use cosine similarity again and also Euclidean distance to measure the distance between the vectors to try to find the nearest neighbors. So at this stage, we were using, sorry, my slides are getting ahead. We were using the PG vector package to conduct these similarity searches. So on the slide, you can see these two poems that we had in the terminal application. On the one hand, Passionate Shepherd to His Love, often attributed to Christopher Marlowe, and then John Donne's The Bait. And you can see right away from the slide, they're pretty similar because early modern poets liked to imitate one another. That was an important part of their creative practice. And so we need the computer to help us distinguish between these two poems. And there they are in 256-degree vector or dimension vector form. I should say that creating these sample vectors for this presentation was an exercise in dealing with chatbots. I obviously didn't want to fish around in the database for our actual vector embeddings, and so I thought, oh, I'll just ask ChatGPT to make me the vectors. And it gave me the exact same vector for the two poems. And I said, hey, ChatGPT, these appear to be the same vector. And it said, haha, I was just showing you what a vector looked like. Like they're not real. And after a few attempts to try to get ChatGPT to actually give me a real vector and it saying like, oh, I'm just telling you what it looks like, I'm not actually going to make a vector. I ended up using Anaconda Assistant, which gave me much better results. It created some pipeline code. When I executed the code, it gave me what I believe are real vectors, but just be wary of the chatbots. They want to please you, and they are sometimes less accurate than the APIs as a result. In any case, these are kind of what our vectors look like. So we were in this stage of working with these similar buckets for a long time. And this is where we started to see some interesting, if not always entirely expected or even always welcome behaviors from the models. For instance, it would sometimes, this is the poem again, it would sometimes cluster translations of the same work. You can see here that we have a candidate group that includes both the English Between Two Brothers, Civil War and Worse, and the Latin Bella inter geminos plusquam civilia fratres. These are, in a sense, the same poem, but we don't want the Latin and English together. I think in a different project we might. For our purposes, we don't because we need to kick the Latin out. And so this is interesting. I mean, well done, model. You have actually identified a match, but in this case, we don't want the match. Another problem that I think we'll be dealing with for a long time, and that I'm sure I will end up writing a chapter about, is the Psalms. Early modern people loved Psalms. They loved translating the Psalms. There are countless translations of the Psalms, and the model has been very good at saying, like, oh, yeah, these all mean the same thing. And it's like, well, they do, but actually, I don't want the Sydney Psalms combined with the Sternhold and Hopkins Psalms. Um, and so we clean it up and then we run the model again, and it says, oh, look, I found a match. And we're back to, so Psalms have been interesting, but really rich. I think we'll be excited about it once we feel like we can move on from data cleaning. So we had a brief period after this long stage of checking these duplicate manuscript items, where we did some more traditional checking using things like regular expressions, or regex, as I referred to them earlier, and SQL queries. These queries came at the problem from two different angles. One addressed items that had only entered the database from a single source on the principle that these might be more likely to include unique items. We also had another query looking for items that came from multiple sources, and this was meant to pick up things that we would see as duplicates that the LLMs had missed for various reasons. There were only about 551 of these out of around, at the time, 100,000 manuscript items, which kind of showed that the LLMs were doing pretty well. It was a good kind of validation of our method. We also did some tidying of people. And strikingly, the LLM-based approaches sometimes missed what we thought were kind of low-hanging fruit with the people. So you can see here 3 different records for Charles Sackville. But then on the other hand, sometimes it did really well. So here you can see the LLM says, these are all variant spellings of the same name. So it's interesting to see where they succeed and where they don't. I think we'll be sort of working through that for a while. So building on this, we've gone back to the LLMs. And as I mentioned, we're now working with a lightweight agentic model to assist us in the final push. And I think we may be getting to our last pass with the LLMs. So I think Jan got excited about all the ERC lingo because he seems to be referring to this system as PRISM, Pipeline for Retrieval Integrated Similarity Mapping. PRISM begins by, I refer to Jan casually, like you all know Jan. Jan is our lead developer. He's great. So Jan has developed this system that begins by calculating 2 new metrics. First, item fingerprints. These are embeddings from both OpenAI and the McBurth models, that include shingles, tokens, metaphone tokens, hash signatures, number of lines, average line length, to try to get a sense of what, a numerical sense of what each item is. These are then compared to what Jan has called a work prototype. This is a representation of sort of the best available version of a work, that we think we have. And this has been a little bit tricky because what actually is the best version of a 400-year-old poem? So when we were designing the model, we thought that, we would give more weight for dates or for extra lines. In practice, it's not it's not always the case that the work with the most information is the best. But it's again, it's been telling us something interesting about the nature of literary evidence. Each of these metrics is then rendered as a single centroid vector. The agent then used our thesaurus of works to search for the closest work in our database. I think that's the next slide. Yep. Um, Generating 2.5 million candidate pairs. These are then ranked into bands using thresholds based on our manual cleaning work. We toyed with the idea of allowing the agent to implement the decisions independently without human review, but ultimately decided against it. The results were encouraging, but they weren't perfect, and we just didn't want to spend a lot of time undoing. So as deployed, the reasoning model also provides an explanation for the match. You can see this is the pipeline continuing, so you can see the review bands here. And then we had considered, depending on the band, just, assigning to a new work, merging. Instead, we just decided to review everything. The model is giving us an explanation of the decisions it's proposing to us, which is helpful for our manual reviewing process, although I was surprised and somewhat chastened to learn from a white paper helpfully called Humans Perceive Wrong Narratives from AI Reasoning Texts, that these so-called explanations do not reflect the agent's actual process, so much as the potential process that it could have followed. Nevertheless, the plausible explanation that it's giving often is enough to sort of point us towards what it's picked up on, and we can go, yes, that's a match, no, it's not a match, and move on. We also briefly flirted with the idea of negative pairs, that is identifying the items that were least like each other. But our excitement about this idea was short-lived, as we had 10 times more negative pairs than positive and concluded that the results were actually unlikely to be helpful. But we did have a moment of kind of delirious, like, what is the exact mathematical opposite of a poem? So we just have some samples here of some of the explanations given. This is a no match, and this is a high confidence match. Um, we then tried to follow a similar process to try to cluster items that remain unassociated with works. This time we tried Facebook AI similarity search, which is a bit faster than PG vector, but the process was otherwise quite similar, generating candidate pairs from unmatched items, computing features, building positive and negative training pairs, training a re-ranker, scoring all the pairs, and then forming clusters. Again, the results are pretty good. Here it's found matches despite variance. I think that's the one. But on the next slide, you can see that it recognizes that items are multiple distinct epitaphs, not variants of a single poem. Recognizing that our authority list was still imperfect, we decided to go back and use the same pipeline to examine the works. And the results are promising, but we actually haven't been able to move from the calculation of nearest neighbors to the re-ranking model yet. So TBD. So there will still be manual review and adjustments to make. But I'm actually not sure, looking back, how we would have linked all these transcriptions to single works any other way, as other than just modernizing everything and obliterating all of this valuable historical evidence. There's no authority list for manuscript poems beyond the big canonical ones, and adaptations, as you see with the Marlowe and Dunn example, are a feature of manuscript culture rather than a bug. It is really exciting to be working in this experimental way, I think, but it also raises some challenges in terms of planning and project management, as I think the postdocs would tell you. Someone who had been working on the team complained at one point that we didn't have firm timelines. But as a principal investigator, it was really difficult for me to set timelines because every time we run the pipeline, we don't know what kinds of results it's going to give us. So to a certain extent, we've had to adopt a more agile-like approach to the project, working in sprints alongside our software developers rather than the more traditional cascade approach where you have milestones and dependencies and you can move at, designated moments, predetermined moments. Some metrics might help contextualize why this is an issue, and also like the current state of things. 68,721 of the manuscript items currently in the database, so about 73.34%. Actually, I think this is on the next slide. Yeah. Are the result of merging two or more records for the same item. Well, 63,355 records have been definitively linked to an identifiable work from our authority list. So this is about 67.61%. But we're still reviewing the 30,348 items that remain unassociated. So this is about 32.39% of the database. At this stage, my hunch is that most of these items are unique, and that's why we're not matching them. But here's the question. It is difficult to know whether we have truly reached a point of diminishing returns with our semi-automated approach, or if there's another tweak to the pipeline, or another model we could deploy, or another new feature that we could implement that would improve our process. So the research team and I are starting to think maybe we need to go back to a more manual review. Jan, because he loves this technology and he's interested in the project, he wants to keep refining the model and testing and testing. And so it's difficult to balance, how do we know when we've reached the best possible results from this process? Because it's an experimental process and we've never seen anyone do anything like this before. I don't know. There's a tension, in other words, between the literary and archival expertise that we've developed through years of training and experience and the temptation to keep refining our model as the technology improves and as we learn more about it. And I think that's an interesting challenge for any digital or computational project. So I'd be interested to hear your thoughts about this. One thing is clear, though. Because everything else in the project depends on this work, there's no future stage of the research that warrants cutting any corners on the data cleaning, even if sometimes we might wish that we could. The quality of our data will determine the quality of our statistical results and analysis. And for that reason, we must continue refining it, either with AI-informed tools or manually, until we are confident that it is reliable. So to conclude, I just want to suggest some future directions for this work and maybe point up some things that we could discuss. We had a project hackathon here in Galway in July, which was a really exciting opportunity to explore the data collaboratively with literary historians, manuscript experts, digital humanists, and data scientists. We plan to share some of the results from these 3 intensive days in a special issue of a journal, which just went to the editorial board for approval. So hopefully I'll have more information for you soon. However, even as this stage of the data cleaning nears its end, our work is far from done. In a practical sense, I have submitted an application for an ERC proof of concept grant to explore the market and user base for a software package that would allow other researchers to use the techniques we've used in a no or maybe low, but ideally no code environment. This project, which I'm calling Archive, will enable humanities and social science researchers and other stakeholders working with nuanced qualitative data to carry out data cleaning work with a new level of independence, lowering both methodological barriers and material costs. Because the underlying technologies are evolving so rapidly, they have not yet been deployed in research software at scale. Putting these tools in the hands of users, particularly people who are subject matter experts but maybe not particularly technical, will drive innovation in research by allowing researchers to work with more data with greater confidence and, probably more importantly, greater independence. In a literary critical sense, I think that there are further interesting, almost formalist questions. The authors of the preprint I mentioned about iteration and benchmarking ask, how do we know whether a given interpretation, as encoded by an embedding, is a good one? But our system has layered on additional metrics, including for formal features, and I think this poses exciting questions and directions for further research. For example, what is it about the epitaph on Sir Thomas Lowell that begins all the nuns in Holywell, which, as far as we know, survives in a single copy in Yale Osborne manuscript FB 143, that for some reason makes it one of the most common items that our agentic system is comparing others to? It's not a popular poem, it's not even a particularly interesting poem, but for some reason, that's the one that the model keeps reaching to as the nearest neighbor. I think there are opportunities to investigate the features that this system is reading, as it were. I mean, I'm cautious of anthropomorphizing, but when it's doing these similarity calculations, what is it seeing that's making it understand it in this way? And how does that change how we read? Another important thing that we have promised the funders is that we will convert our relational database into triples by the end of the project to facilitate interlinking. This is partly to facilitate enrichment of the sort that other database projects aspire to, but it's also an important way to future-proof the work. We are required to deposit our data, and we aim to do so in a non-proprietary platform agnostic manner. If at some point in the future a lack of continued funding prevents maintenance or upgrades that will lengthen the life of our web application, that data should still be usable somehow, somewhere, which given its origins only seems like the right thing to do. So in a recent preprint, a group of authors led by Cody Kommers argued, meaning is not a metric. Thicker representational formats are needed to render human meaning legible at scale. Our agentic system may offer just such a format. We have developed it to serve a very particular practical problem through a defined project, but it may also be scalable for similar purposes. But it works precisely because it overcomes this humanistic challenge, showing why this collaboration has been so very generative. Thank you.
Wonderful. Thank you, Erin, for that really inspiring presentation. It's great to, I guess, hear the update on the project. I guess, yeah, a little over close to a year ago, or yeah, 7 8 months
Yes.
ago. So yeah, a lot's happened, and it's very interesting to hear about your hackathon over the summer as well. And we look forward to seeing the journal special issue, I think you said,
Yes.
coming out of that. So that's all very exciting. So the normal way we do things is people type their questions in the chat. And can you see the chat there, Erin?
Yes.
Is that okay? Oh yeah, okay. The questions are coming in quick and fast. So I don't want to monopolize things too much. But maybe while people are typing, I might ask just a quick opening question,
Sure.
and then we can move on to the questions in the chat. So agentive AI is the big sort of buzzword at the moment. It's the thing that's going to replace, all of us essentially. So I'm wondering, you mentioned your lightweight agentive model. I'm wondering specifically what sort of agentive features are useful to you in your pipeline, and which model is it actually? I don't think I remember. Could
So
you talk a
I,
bit more
I
about
can,
that? Yeah.
yeah, I can back up to
Yeah.
there we are. So, essentially, I mean, it's agentic insofar as it's layering multiple processes together. We
Okay.
haven't granted it a huge amount of agency, because we don't fully trust it, which I think is important to say because, I think we get nervous that these things are going to replace us. And
Indeed.
I won't even let it merge database items unsupervised,
Mm,
because like it's pretty good, but it's not perfect. And if it merges things that shouldn't be merged, we may not find them again for a few years. Um,
mm,
so so I don't think we're in any danger of being replaced just yet, but it does help us. So I'll try to walk through this diagram a little bit more slowly. So we have here the inputs, and here we're just kind of pre-computing the metrics that it's going to compare. Here we get it sort of running calculations over these and suggesting candidate pairs on the basis of those metrics. And then where the model becomes useful is with this re-ranker. So what we had been doing before is using vector embeddings to just create buckets or pairs or just groups for us to review.
mm.
But now the re-ranker is actually dividing these into bands. And this is where the
Uh,
trust issue became relevant, is in this gray box. Because originally we were going to say, okay, anything where you're 95% confident that it's the same thing, just go ahead and link it. And actually, at
mm.
the 95% level, it's doing pretty well. It's that review band where things get really sketchy.
Okay.
And that I think has to do with the nature of early modern poetics. And that's been one of the things that's been really interesting to work through. And I actually need so what I was going to say, it's been interesting to work through with technical people because you know, they're technically great. They know this side of things way better than anyone on my team does. But they don't know the quirks of early modern poetics. They don't know about imitatio. They don't know about the Horatian edict to teach and delight. And so things that seem like second nature to me, like, well, of course John Donne is imitating Christopher Marlowe. Like that's the game.
Hmm.
The developers are going, well, these kind of look the same. Like, why can we not just merge them? Now we've been working together now for 2 years. And so, and Jan in particular, we think might be secretly reading about manuscripts and or early modern poetry because he's starting to say things where we're like, why do you know this? And so we have some really interesting videos from the hackathon where um, we had a media crew that was doing interviews and they were asking the guys like, well, what do you find more interesting, poetry or manuscripts? And so they were getting into these like almost literary philosophical debates about like the nature of evidence and I was um so it's been interesting to see how the collaboration has kind of changed our thinking both ways, I think. It's opened up my team's perspectives about what's possible technically. But
Hmm.
it's also kind of challenging the developers to think about like what are these systems doing? Like, what do we want them to do? And so that's been really, I think I've kind of digressed a bit from your original question about the agentic model.
Yeah.
But yeah, it's been really interesting to see that we've all kind of gone like, yeah, these models aren't getting it. They aren't understanding that like what early modern poets are doing is I mean, or they are exactly understand. Like it's like I said with the Psalms, like they're either the models are either kind of getting it or not. And now here I'm anthropomorphizing them again. Because of course they're not getting anything. They're just doing math. And
Yeah.
they're recognizing similarities that are really there. But this is the next step in the model if we were to allow it to run on its own, is it would take the decisions and kind of update its parameters, but we
Yeah.
haven't been
And
able to allow it to run free yet.
and I guess you just have the incipits, right? The first lines. Or
So we always have first lines. We often have second line, or no, we often have last lines, and we
okay,
sometimes have second and
explain.
penultimate lines,
Okay.
but it depends on the data source. So like for
Yeah.
research, we always have first and last because I insisted on that as a postdoc 10 years ago. Um,
Okay.
yeah, but for and like Josh Eckert transcribed 4 lines from everything, but then
Oh,
some
wow.
things like the Folger only have one. So and then
Ye-
with Kelm for extra fun, because Kelm has XML, sometimes what it presents as the first line is not in fact the first line. Like
yeah.
because it's pulling from a record for a work rather than an instance for like a specific manuscript instance. So
Oh, I see.
and
Okay.
so all of that
Some like
logic has
textbook
had to be
version, but it's not actually what's in the manuscript.
exactly, and all of that logic has had to be coded into these various
Okay.
processes at different, so like for different fields, we'll sort of prioritize different sources. There's a cascade, prefer this one and then this one and then this one.
Yeah.
So it's
Wow.
been an interesting. Jan's been very patient with it. I think a different developer might have lost his mind by now.
Yeah. Is that good?
Like, what is wrong with this data?
Good to
And
know he's
and
mentally strong. That's good.
well, my excuse is always like, what do you want from spreadsheets made by English professors? Like,
Hmm. Good, good. So yeah, maybe we should move on to
sure,
the onto the questions because I don't want to deprive other people of the
okay,
opportunity to ask you a question. Yeah, maybe do you want to take a look at them rather than me
sure.
reading
Should I just
aloud?
read the questions out and answer them? Is
Yes,
that
yeah,
how
that's
this is
maybe
usually?
easier, I think.
Okay. So the first question is, my question is, how might the macro level patterns revealed by STEMMA guide scholars back to individual texts, perhaps helping us to identify new previously overlooked manuscripts as uniquely significant case studies? This is a great question, and this is one that I addressed in my pilot study. So once we're able to get into the network model, we're able to see poems operating kind of within a bigger structure of information transmission. And so by using network science, we're able to see things, sometimes things like co-occurrence, like why do these two poems keep popping up together? That's interesting. But also poems that maybe span communities. That was one that I explored in my case study, or in my pilot study. Why are there particular poems that seem to appeal to a wide range of people. Another dimension that I'm interested in, and one of the reasons that these 225,000 unique date values had to be addressed, is change over time. I think there's a difference between a poem like the libels on the death of the Duke of Buckingham that sort of proliferate really quickly and then burn out versus some more. So I'm thinking particularly of a religious poem that's ascribed to Elizabeth I and to John Donne, and it's not by either of them, but it circulates for about 100 years. And that's a really different thing than something that kind of burns bright and fast or something that endures. And I think these are, questions that we haven't been able to ask before because we've never had all of the evidence aggregated in quite this way. I hope that helps. Do I wait for a response or do I just...
I think, yeah, you can move on to.
Okay, great. The next question for undergraduates, how can one balance traditional historical methodologies with digital techniques? That's a tricky one. I think probably the best way is to kind of give the digital methods or techniques maybe one at a time and in a very applied way. So as an example, I taught a women's writing course in Australia in my last semester there. And I had them, rather than writing essays, I had them create a wiki to bring these kind of lesser known women and their works to light. And so it wasn't a DH course. None of the students had built wikis before, um, but it was a way for them to kind of learn a method but not at the cost of developing the subject matter knowledge that makes them credible when they're doing these projects. So, I mean, it's really tricky to be a digital humanities scholar at every level because you almost have to master two fields and two very different ways of thinking. The epistemologies of digital humanities, particularly as it slides into something like computer science, are quite different from literary history or regular history or religious studies. And so trying to keep those two things in balance and being able to translate between audiences is a real skill. And I think it's great that you're thinking of that for your undergraduates. Question about one mode projections derived from bipartite networks. I think one reason the one mode projection is so important is that so much of this material is anonymous, and we haven't been able to network it easily because we've been looking for the human agent to peg it to. Where by kind of taking humans out of the equation, we can start to see where manuscripts are connected. And then if we have one shred of human evidence anywhere in that sort of neighborhood of the network, we can start to, I think, I mean, we'll know more once we actually are able to get into the modeling, but I think then we might be able to find ways into that network community. So to give a concrete example, there's a cluster of 3 manuscripts created by a Jesuit missioner. And when I put these into the pilot network with no evidence about the compiler, it clustered those manuscripts because there were shared contents. And then because I knew that was, and I knew from traditional scholarship, this is not my insight, but I knew that one of those manuscripts was created by that Jesuit. Then I was able to see like, oh, actually this whole network is his work. And also there's this other manuscript that's not in the network, but I know it's in Trinity College Dublin, and that's also by him. And so that's really how we can start to, it's by almost by taking the people out of the equation and working on the level of unique identifiers, we're able to kind of find the communities and then add the people back in and reconstruct the human agents around that. I hope, Stuart, was that clear?
Yes, that was great.
Great.
That's very
Okay.
good.
Excellent. Thank you. Um, the next question. I am a history major who is focusing on Chinese ancient wooden and bamboo slips. That's cool. Can you please tell me if there is some difference in dealing with manuscripts of different languages? In addition, as a student in Faculty of Arts, the techniques are too difficult for me. Could you please tell me how to start with your area? Okay, first, that is completely fair. And again, this is what I was saying about the difficulty of translating between audiences. I also have had students who will not say that they're too difficult, but that they hate them, or that they did English so that they don't have to do math, or that it's making them nauseous. So I'm very sympathetic. I think the way to get started is to start with the kind of digital humanities scholarship. starting with Ruth and Sebastian Honor, they're kind of the godparents of this whole field. Ruth is a literary historian and Sebastian is a physicist, and they write probably the clearest introductions you will find, and just follow the trails of their references, and they will get you to the mathy bits. They're difficult, but I think once you kind of see how they apply, it makes it easier to understand them. And I hope that I didn't give so much detail that I lost you entirely. In terms of whether there's difference in dealing with manuscripts in different languages, I would encourage you to look up the work of Dr. Jing Chen, who is also based in Hong Kong, who's doing kind of a similar project, but with classical Chinese anthologies. Her work is fascinating, and when I learned about it, I immediately wrote to her and invited her to Galway, and she said, "Who are you? Why am I coming to Galway?" Now, a year later, we have developed a friendship and she's spoken to us virtually. But I was just so excited to see what she's doing. So there are absolutely going to be nuances in the way you use the tools, or in, I don't know as much about Chinese ancient poetry, and so, maybe there aren't as many issues concerning imitation, or maybe scribes were more faithful in their copying than English scribes tended to be. So you would be, as the subject matter expert, better placed to know how that would vary, but the mathematical techniques will be similar. Um, Thank you. So the next question, is there any way to recover old databases or documents to make them easier to search and identify? What role did AI play in the process of recovering these things? So we haven't had to recover things, thankfully. But if you're interested in things like handwritten text recognition, there's a great AI platform called Transcribus. And it's actually developed by scholars for scholars. You can buy a membership and transcribe things automatically. It's very powerful, but what's great about their membership is that money's not going, it's no one's profiting from this. It's going back into Transcribus to make it better. So it's a really exciting piece of technology. We fortunately haven't had to try to recover text ourselves, although one of the work packages is focused on stylometry and full text. And I think a different researcher might use automated transcription. The person who's doing that work wants to go do her own transcriptions because she wants to do handwriting analysis, and I'm not going to stop her. She's a great paleographer. But there are ways that AI can facilitate recovery. We just haven't had to do it. The next question, when reconciling different manuscript versions, how does AI determine whether a textual difference is a copying mistake or a deliberate editorial change? It doesn't, because even humans can't agree about this. Sometimes you can guess, but sometimes you can't. And that's why I didn't want to modernize things. Because, you might think that something is a mistake and that you can fix it easily, but it might not be. It might be something that the person copying that poem really wanted there for some reason. And so we need to keep it there until we can amass enough evidence to determine through traditional literary methods whether it's a mistake, whether it's a meaningful change, or whether we just can't tell. But we need that evidence there so that we can decide. So we don't let the AI make those decisions. It's beyond its expertise. Next question. Thank you. Um, I found your explanation about detecting plagiarism through Turnitin very interesting. Could you elaborate on the detailed mechanism behind how Turnitin identifies similarities and distinguishes them from properly cited sources? That's an interesting question. I think any of you who have used Turnitin know that it doesn't always identify similarities and distinguish from properly cited sources. Sometimes it will tell you that something that's clearly in quotation marks is plagiarized, and as the expert human assessor you're saying, no, it's not, this student cited this correctly. So I actually, when I became a fellow of the Higher Education Association, that's what it is, I actually used one of my essays to complain about Turnitin. I'm not a big fan, because essentially what it does is it collects students' work, it ingests it all into a database. Students don't know this, they don't consent to this, and then they bundle this and sell it back to the universities at cost. So the universities are paying to buy back their own students' work so that it can run locality sensitive hashing over it and then suggest possible plagiarism, and it's not always accurate. So I'm just not a big fan of Turnitin. I think if we're designing our assessments well, and if we are assessing our students and know them, we probably have a better sense of whether things are plagiarized or not. I think generative AI throws a whole new spanner in the works. There's no clear way to distinguish the results of generative AI. And so I think we probably just need to get more creative about assessment design. Um, but
Yeah,
but it's been a while since I've thought about that.
there's a very interesting recent article in the Chronicle of Higher Education that some people on the call might have read. It makes exactly your point,
Oh, great.
with some rather colorful examples. So
Oh,
I'll check
wow.
that up.
Okay, I'll have to look for that. Yeah.
Yeah.
Thank you. Do we have time for a few more or?
Yes. Yes, definitely. We have another 4 minutes. So
Oh, great. Okay. So the next question, in reconciling multiple sources of manuscript data, are there any biases or gaps in the archival record? Always. So rich people's stuff always survives at a higher rate than poor middle class people's stuff. Why? Because they have libraries and they have grand country houses and things just get tucked away in trunks. The oldest surviving autobiography by a woman, the Book of Marjorie Kemp, was found in a cupboard in the 1950s because someone stepped on a ping pong ball and they were looking for another ping pong ball and they pulled out a 14th century woman's manuscript. Um, so yeah, I mean that's the big one is class. Obviously gender, men's writing tended to be taken more seriously and therefore preserved more carefully. Dominant cultures tended to have their writings preserved more carefully than marginalized cultures. One exception to that is that we have a lot of Catholic writing from the period because it was illegal to be Catholic. Um, Catholic people often couldn't publish their works in print, and so they were driven to manuscript circulation, and that's why you find a lot of interesting books and letters that were circulating, and these are often moving geographically more than more permitted books, because it's illegal to be Catholic. So people are hiding in France or in Belgium, or people move to what is now Massachusetts, because they're Puritan and they feel, and so that's where you sometimes get manuscript production from marginalized peoples. But yeah, the dominant cultures tend to have more records than not. And so I'm hoping that by amassing things, we can start to see what survives and where things might be missing. And that's where the predictive statistics become useful. How would you recommend students to use AI to improve their abilities in order to be competitive in society? That's a really interesting one. I think probably more than using the AI to improve their abilities, I think understanding AI, how it works, what it can do well, which it can do some things well, what it doesn't do very well. I think being able to think critically about AI is probably more important than any one use of it at this stage, because I think once you understand it, then you start to see how it might be useful. But until you understand it, you're either going to be all in and excited about the AI, or you're going to be scared of it. And I see both in my day to day, and neither is ideal. And I think, knowing what it's helpful for, it's great for this kind of work. But what it's not great at, I asked it recently, what are the major editions of Amelia Lanier's poems? And it was like hallucinating this Manchester Press edition. It meant the Penguin edition that was sitting on my desk, but it kept telling, it was giving me the wrong date. It was the right editor, but the wrong date and the wrong press. And I said back to the chatbot, like, that book is on my desk. You're clearly wrong. And it's like, oh, sorry, I make mistakes. Haha. And so that's why I think, teaching students, what it's doing, really. They don't need to get into deep into the math, but knowing its probability, it's predicting the next most likely token, and sometimes it gets it wrong. I think that's probably the most important thing. One more?
great. I think
I'm
we
sorry,
just
I
reached
feel bad. There are
5:30.
so many
I
questions.
know, I know, I know. Well, it just speaks how interesting your presentation was.
Great.
It's evoked a lot of questions, which is great. Yeah,
Thank
tremendous.
you, everyone.
So yeah, just a reminder to everyone, our next meeting will be on Tuesday, November 4th at 9 a.m. Hong Kong time, when we'll be hearing from Professor Jessica Pressman from San Diego State University, who's going to be speaking to us on the topic of digital humanities and slash as electronic literature. So I look forward to seeing many of you there. I guess all that remains for us to do is to thank our speaker coming to us from Galway in Ireland. We're yeah, tremendously grateful for her taking the time and look forward to seeing, well, and hearing more about the very exciting STEMMA project.
Thank you.
Professor McCarthy.
Thanks, everyone. Bye.
Bye.